Okay, so what our goal is we're going to take this trinomial, this quadratic that is in standard form, and we're going to change it into vertex form. We're going to do that by using complete the square. I'm just going to write what I'm saying down really fast. This is called complete the square. So I'm going to go through the steps of how we do that. First thing that I want to do is I want to move the C to the other side. So I'm going to subtract 5. Okay? When I subtract that 5 and I rewrite my next step, since I know what I'm doing, I know that I need to leave a space. You don't know why I'm leaving a space yet if you don't remember complete the square. So just go with it for a moment. So I subtracted the 5 to the other side. I left a space on purpose. Okay? Now, to put in that space, we are going to add something to both sides of the equation. And I chose to put it in a square because this is called complete the square. And what goes in the square is a square of a number. So I use a square. Okay? The next thing we have to do is we have to figure out, and in Algebra 2, we spent more time to go through this process. We have to figure out what I can put in this pink square so that when I factor this equation here, when I factor it, I get a perfect square, like 2 binomials that are exactly the same. So if you're really good at factoring, you might be able to look at that and tell me what goes in there. There is a formula if you're not that great at factoring, just to speed it up. The formula is to find the new C, we are going to take the B value, divide it by 2, and square it. So this is the formula to find out what goes in the square. So my B value is -4. So I'm going to do -4 divided by 2 and square it. Now there is a reason why I am writing out all of these steps, but you can't read my mind, so you'll find out in a moment why I'm not just writing my answer of 4 down and why I wrote out the steps. Okay? So 4 is what we get when we divide B by 2 and square it. When we divide -4 by 2 and we square it, we get 4. So that gets added into both sides of the equation. Remember, if we do something to one side, we have to do it to the other. Okay? Now, if you're really good at factoring, you should be able to tell me right now what goes in the rest of this binomial x. Anybody? What is it? Yeah, -2, -2, yeah. Subtract 2. X minus 2 is what would go in there squared. Now, if you're not that fast at factoring, I'll give you a little cheat. And it comes from the reason why I wrote out my work. So if you're not that great at factoring, looking over in the work here, this step right here before I squared it, that's always what goes right here. Every single time. Okay? So if you don't even want to take the time to factor it, that's the number that goes there. It includes the positive or negative sign. All right, so our next step, I did not simplify the left. Oh, no, hurry. Oh, I saved it. Okay, the next step is on the left side. I just need to simplify y, take away 5 plus 4, so y minus 1. All right, there's only one more step. I'm going to add 1 to both sides. So I will get y equals, and on the other side, x minus 2 squared plus 1. This is vertex form. Now, that may have taken a few moments for me to explain all of the steps and do it with you and ask you questions. But when you do it yourself, that's really not that much work. And when it's in vertex form, I should be able to look at it and find the vertex. Anybody yell out the vertex for me? 2, 1. Axis of symmetry, x equals 2. I can make a transformation table and find other points really fast. Or there's no stretch or shrink on this one. As long as I know where the vertex is, I can just like pattern it up and have it graphed instantly. Well, in a couple seconds. Okay, I'm going to do another one like that, but I'm going to take it from the last page. The last page has some graphing questions, which is what you did yesterday, but these are starting out in what's it called? Standard form. Thank you. I think I'm going to do this one here. Lucky 13. We'll do lucky 13. Okay, so I'll go through the process of changing that into vertex form and graphing it just to see how fast we can do it. And then I'll leave you some others to practice with. All right, so vertex form again. The first thing that you want to do is get rid of that C value. I feel like you don't really have to, but I feel like it's less confusing to just move it to the other side. And when I move it to the other side, I now have y plus 1, and then I'm going to leave a space, and then equals x squared minus 2x. In that space is going to go my square. So now we're going to find what goes in that square by finding a new C value using the formula b over 2, or half of b squared. So negative 2 divided by 2 squared. Negative 1 squared is 1. So I'm putting 1 in both places. Now I'm going to simplify the left, y plus 2, and factor the right. So I'm going to have x, and then I look at what number I had before I square it, which is a minus 1, and squared. So x minus 1 squared, it's factored. Subtract 2. Y equals x minus 1 squared minus 2. I have vertex form. And that was pretty fast, even with me talking the whole time. You guys get rid of me talking, then you can go way faster. This does ask to find the vertex, to find the axis of symmetry, and to graph it. So vertex, remember we do opposite of what's in the parenthesis. So that'll be a positive 1, negative 2. And then the axis of symmetry would be x equals, the same as the vertex x, 1. So my graph, 1, negative 2. And my axis of symmetry, I'm going to go ahead and put that on the graph so I can refer to that to help me graph it faster. There is no stretch or shrink. If there were a stretch or shrink, I'd make a table. There's no stretch or shrink, so I'm just going to use the normal parent function pattern. And from the vertex, we go out 1, up 1. From the vertex, out 2, up 4. Out 3, up 9. And then mirror it for efficiency. So I graphed that really fast too. I didn't even have to make a table for that one. So where I might want to use vertex form in the future would be if I've got to find all this information, it might just be faster for me to change it into vertex form rather than try to do in standard form b over 2 or negative b over 2a squared. No, see, now I'm confusing my formulas. Negative b over 2a to find the AOS, plug that in, and then that only gives you this piece of information. I can't use transformations if it's in that form, so then I have to find x-intercepts and y-intercepts or other points. It's there's like a lot more work to do it if it's in standard form sometimes. Sometimes, though, it might be faster to do it in standard form. And I'm going to let you decide that when you start just having to graph it on your own. Okay, there is another kind of these that has like 2 extra steps. And it would be any question that has a number in front of the x squared, a coefficient, an a value that is not 1. So any of these that have an a value that is not a positive 1, you're going to have to do this extra step. So I'm going to do number 5, and then I'll pick one other to do. Okay? So if we have a number in front that's other than 1, we still start the same. Add 12. So we still start out exactly the same. Step 2 now, this is an extra step. You cannot do the b half of b squared, b over 2 squared. You cannot find the new c value if there is a number in front here. You cannot do it. It will not work correctly. It only works if there's no number here. So I'm going to manipulate this, and I'm going to get rid of that number. Now, I can't just like poof, magically make it disappear. I have to mathematically manipulate it by factoring out -2 from everything on this side. It's not going anywhere. It's still there in front. But when I divide whatever this square value is, when I divide whatever this square value is by -2, it's no longer the same number. So I'm going to put a different symbol here, because if I divide square by -2, it's no longer pink square. So I might put a purple fluffy cloud. There we go. So that's just going to be a different value. So I gave it a different picture. Okay, so now we're going to do b over 2 squared with our new b value. That's going to give us a different answer than the one above it. So with the 6, instead of -12, I'm going to find our c value. B over 2 squared. So 6 over 2 squared, which is 3 squared, which is 9. So 9 goes in this spot here. If you have a question while I'm doing this, please stop and ask. Put your hand up or yell out. I just feel like I could go faster because you guys aren't talking, but I feel like I can't go faster. All right. 9 doesn't go in the pink square. Because what I did, if you look at the step above, pink square divided by -2 was 9. Okay, pink square divided by -2. So whatever's in the pink square, I have to go backwards. Anybody want to guess what I have to do to this 9? I had to multiply it by -2. There's another place you might see this. If I just look, this 9 has a -2 out front of the parentheses. So I'm adding, by putting a 9 inside the parentheses, we have to keep in mind that's -2 times 9 that we're actually adding to the side. What am I actually adding to the other side? So I confused you because nobody answered. And nobody's answering that either. Let me try that again. 9 completes the square in black. It makes that a perfect square. But outside of this parenthesis, there is a number multiplying. So if I put a 9 in this spot, I didn't put a 9 on the whole side. Because if I multiply this -2 back in, what did I actually add here? Negative, I did not hear negatives. I heard 18, but maybe you guys said it, but just not very loud. So what I'm actually adding to this square is negative 18. So over on this side, we have to put negative 18. So that's the other extra step. So we had to take out the negative 2 to find the 9. Then we had to put we had to put the negative 2 back in to find the negative 18. Those are the only extra steps. So now we go back to the original steps. The next step would be to simplify this side. Y minus 6 equals, and on this side, the negative 2 is still out front, but I'm going to factor x plus 3 squared, where this number, before I squared it, is that number in the parentheses. So that part's all the same. It's just you have to take out the negative 2, then you have to put it back in. And then finally, add this 6 to the other side. And we get y equals negative 2 x plus 3 squared plus 6. And we have vertex form. I'm going to try one more of those, okay? Any questions before I try another one? All right, let's do 8. Let's do 6. It doesn't matter, 8 or 6. Let's do 6. First step, move the 18 away. Get it over there. Okay, so I'm going to look right here, and I'm going to say I cannot do complete the square yet, because I can't do it if there's a number in front of x squared other than 1. So I got to take that number out. So I take out the 3. In my parenthesis, I have x squared plus 6x, but I don't have pink square anymore. That's not a pink square anymore. And you don't have to use my silly symbols, but I just like to use the purple fluffy cloud. I just like to use it, because that is just some other value. It's not whatever's in the square. It's some other value. But that is the value I'm going to find. I still have the same answer as the other one. Oh well. So we're going to do C is b over 2 squared. So we do 6 over 2 squared, 3 squared, 9. So I had 9 both times, but it's not going to be 9 in the pink square. And somebody tell me what is going to be in the pink square? 27. So we took out 3 to get 9. We put it back in to get 27. So that's what goes in pink square. You can also think about that 9 having a 3 in front of the parenthesis. There's another place that I can see that it would be 27. All right, I'm going to go off to the side here. So now I have y, what's negative 18 plus 27? 9? Is it 9? Then my 3 is going to stay out front. I'm going to factor x plus, if you're not sure what number goes in there, it's what you had before you squared it. And then subtract the 9. And from there, you can quickly find the vertex and the AOS once you got it into vertex form. There is a stretch or shrink. So if I were graphing this one, I would make a table. That's what I would do. Other questions that I can have on this video before I turn it off? Anything you think of? Okay, so your quiz tomorrow will just be taking an equation and putting it into vertex form. I'll probably give you one that starts with a 1, x squared, and I'll probably give you one that doesn't. I might ask you what the vertex and AOS is. I haven't decided if I'll do that, but that should go quick. I might not. But I will tell you, I'll definitely give you one of each. So you need to be prepared to do one of each of those. Yes?
Is there also a way to do it for factored form to vertex form?
To do factored form to vertex form, so sort of. I'll say right now, factored form I think is really easy to have it already in factored form to find a lot of information. So I personally would leave it in factored form. But if you, I'm just making one up right here. If you wanted to do it, you would just have to put it into standard form first and then go to vertex form. To me, that's too much work where this gives me the x-intercepts. And with the x-intercepts, I can find the middle. And yes, I have to plug it in, but it's just faster than changing it twice. Okay, so that's a good question. Any other questions before I turn off the video? Now you're just like, nope, I can't wait to start. Right? Okay.